Hey everyone, welcome back to the channel. My name is Dennis and welcome back to 1 Year 365. And today we will discuss about ground or electricity. The reason why I want to discuss about this is because I do have a question actually. The question actually revolves around my understanding about the concept of grounding. So if you don't know, grounding is when you ground something, I guess, or um, when you transfer the electricity to the ground or to the earth, so that it can prevent things like short circuit or like overcharge or something like that. And yeah, um the grounding makes sure that it is safe basically. So I don't know if that even true or not. So yeah, my question is that because it got transferred to Earth, right? And then Earth is supposed to absorb the electricity, or to neutralize. Now my question will be, it's a little bit of crazy question. I think my question will be as simple as what how much electricity is needed so that you can actually um, make earth into not resisting but actually make earth conducting all of those electricity. And yes, it means that it will electrocute everyone on earth, or everything that touches the ground, I guess. Yeah, that is my question. Like, how much of energy of electricity you need to turn or to be able to make earth like surrounded by electric, or transfer electricity basically. Because my understanding of electricity is that it will flow, but if there is a resistance, it will choose to go to the one or path that has less resistance, right? And that means if a thing has a little bit too much resistance, then the electricity simply will not flow through that path, basically. Which we can actually, with that simple understanding, we can actually think that Earth is actually a giant resistance. And my question is that how big energy of electricity that we need to make it able to pass through Earth, which means Earth will become electrocuted, and that means everyone else or everything else that touches the ground will be electrocuted as well. So yeah, I don't know if that's possible or not. Mathematically speaking, that might be possible, right? But I don't know how, the mathematical number. Maybe it's too much that it makes it impossible. It's just because of the fact that it has a lot of numbers. Might as well that it's impossible to obtain that in the first place. Or maybe it's in the case where it it is impossible in a way that the earth is actually non-conductor. But I don't know about that. There's water, obviously. The earth is moist, right? Like it's not like it's dry. So maybe there's something there, I don't know. But anyway, we'll actually, I guess that is the question. I doubt that will be explained over here, but I guess we can discuss about the concept of grounding in general, so that we can, have a better understanding if the question makes sense in the first place or not. So yeah, let's start with this. I'm just gonna make it short, I guess 10 minutes or something. So yeah. Um, in electrical engineering, okay, ground or earth is a reference point in an electrical circuit from which voltages are measured, a common return path for electric current, or a direct physical connection to the earth. Yeah, direct physical connection. Again, you know, why? What makes that earth is not, connecting those electrons? electricity elsewhere, or electrocuting everyone. I guess it makes sense. Like I said, it's because it's too big of a resistance. But yeah, if that's the case, then how much? Again, back to the question: how much energy is enough? So yeah. This one is a picture, a typical earthing electrode. Okay, left of gray. Okay, um, oh, left of gray pipe. Okay, consisting of a conductive rod driven into the ground at a home in Australia. Okay, most electrical codes specify that the insulation on protective earthing conductors must be a distinctive color or color combination, not used for any other purpose. Yes. Electrical circuits may be connected to the ground for several reasons. Okay, here we go. Exposed conductivity parts of electrical equipment are connected to ground to protect users from electrical shock hazard. Okay, so it's for safety, I guess. If internal insulation fails, dangerous voltages may appear on the exposed conductive part. Connecting exposed parts to ground will allow circuit breakers or RCDs to interrupt power supply in the event of a fault. Okay, so I guess connecting to ground means that, again, because the earth has too big of resistance, then the electricity is not flowing, and it has something to do with the circuit breakers, I guess. Maybe it will get overloaded or overcharged, and it will pop and it will turn off the entire system. I don't know, maybe that is the idea. To interrupt power supply in the event of a fault, yes. In electrical power distribution systems, a protective earth conductor is an essential part of the safety provided by the earthing system. Yeah, I guess for my fellow electrician or electrical engineering, I guess you all know about this one, right? I mean, yeah, I'm also an engineer, so it's like common sense basically. Connection to the ground also limits the build-up of static electricity when handling flammable products. Yes, this is very interesting because I'm chemical engineering myself, right? And there's been cases in like a petroleum industry where their tank, like literally storage tank, got struck by lightning, and that causes fire and it blows the tank, and yeah, it's quite a devastating disaster. It happened like quite usually, actually, unfortunately, like in 2020 there's one that happened, in 2021 there's also another one that happened, and it's just bad. And yeah, it's like catastrophe that shouldn't happen in the first place. So it's like a faulty electricity thing, I think. Yeah, it got struck by lightning. Maybe they don't have the earthing. I have no idea. Maybe they didn't think about that. I have no idea. Maybe they do have, but somehow it breaks. It broke, or I have no idea. Again, literally have no idea. Well, I guess only the government that are charged to, or ordered to investigate the accident, know about what actually happened. So yeah, but I guess by the press release though, it just mentioned that it got struck by lightning. The storage tank, it creates fire. There is the pressure, like vapor, flammable. It like it got burst into flames, and it creates lots of carbon dioxide, builds up, pressurized, and yeah, explode. And yeah, unfortunately though, I think there actually was casualties. I don't know how much, but or how many people, because of that, died, but there were actually some casualties. So yeah, yeah, I guess it is what it is, right? It's not what it's supposed to do. I mean, it's not how it's supposed to be, but it happens. So yeah. If anything, it just becomes a lesson learned for the future. So yeah. Anyway, let's continue. Excuse me. It's just it comes back. So I record videos by my window area, and there's the curtain, and the curtain has never been cleaned, and there's a lot of dust gathered up. which means that yeah, I always breathe dust here. And I mean, I also did clean sometimes, but it's just gonna build up again, right? And I guess it's now affecting. Sometimes it affects immediately. Sometimes it takes time. Like this one, I've recorded 5 videos, nothing happened, and somehow my nose is very itchy now because of the dust built up. So yeah, but anyway, let's continue. Uh, History. I guess it's probably the history for how they invented this earthing system. Maybe I don't know. Building wire installations. This might be something. Let's actually read this one. Electrical power distribution systems often connected to earth ground to limit the voltage. Okay. Let's see about is there any example like how it is actually used practically, right? Like what thing actually? Excuse me a second. It's just so itchy. I cannot stand. Anyway, um, I need to purposely sneeze so that I can like have something to deal with it basically. And no. Otherwise, it's just gonna stick there and it's gonna make me feel itchy. I need to sneeze actually. I don't have my tissue with me, so yeah. We'll do it later, I guess. But anyway, let's continue. Um, hmm. What is this? What is this? Metal water pipe used as grounding electrode. Huh. I don't know what this is about, but I might have an idea because I think I know a little bit about this one. So, basically, water pipe system. Usually, you want hot water or cold water, and the way they alter the temperature of the water is by heater, and sometimes they use um, like gas, I guess, like like oxy, not oxy, a gas can, gas, like literally can, like spray can, but it's a gas, and it will, creates fire, and it will heat the kettle, and it's filled with water, or hit the pipe, I guess, and it has the water in it, so you get yourself some heated water, then you can use that maybe for I don't know, like uh, uh, bathing or hot tub or something like that, whatever you want to do with that. um, and sometimes there is also heater that use electricity, and this is interesting because electric heater, obviously it requires electricity. It kind of creates a coil or something where it will transfer heat, and the heat is generated by electricity. But sometimes the electricity can actually leak, and because everything there is made of like a metal, then the electric can actually travel through all those components. And not only that, the pipe itself is actually made of electric, not electric. The pipe itself is made of metal, like this picture over here, and which means that if electricity leak happen, um, it can actually flows through the entire pipe system, which means that it might be dangerous if you're actually like using at the moment using the shower, for instance. You tap the valve, and that is metal as well, so you might actually get electrocuted. I think there might have been some instances when that actually happened, but yeah, that would be very unfortunate and very very dangerous, hazardous, right? So yeah, it makes sense that they have earthing so that in case of electric malfunction, like the thing, I mean, like the short circuit or something, it doesn't actually spread through. It will just trigger the brake. Not brake. What is it again? What is the brake system again? I think it's just brake, right? Yeah, it will break that. It will break that, and it will shut down the entire like electricity, right? So it will cut the power. So yeah, so that such thing never happens in the first place. That is one thing that I know. I don't know if this is that or if this is something else, but yeah. Anyway, I think that will be it for this one. I just kind of want to, um, I just want to, ask the question that I have mentioned previously about, if if you can actually make Earth into be passable by electricity, if that is possible or not. If it's so possible, how much of energy, like a watt or I don't know, megawatt or something that you need to transfer to Earth, and then it will get transferred to the other side. I don't think it, I don't think it's possible, but I don't know. But yeah, I don't know. Also, by the way, if you like electrocute a spot in the earth, for instance, on the ground, what happens if there is a person standing next to it? Will they get electrocuted as well? That is also another question. Does it affect the range from you or person from the location of impact, right? Like a spot. I don't know if that's a thing or not, but anyway, I think that'll be for this one. It's just a question. If you know the answer, let me know. But anyway, I think for this one, I hope you guys enjoyed. Stay just healthy. I will see you again tomorrow with another discussion, which will be probably a little bit less random like this one. But anyway, until then, see ya.